Hi, in this video we're going to look at the graphs of logarithms. Now, as I mentioned in the previous video, logarithms are linked with exponents, and so it'd be worthwhile looking at these two things together in terms of their graphs. So we're going to look at the graphs of exponents and we're going to look at the graphs of logs. So last year you would have done this graph, the graph of the exponential function. Let's say y is equal to 2 to the power x. So if we get a version of that, we can plot it and put it into this page. There is the graph of y is equal to 2 to the x. Now, we now want to look at what the graph of, we need a pen active, the graph of y is equal to log to the base 2 of x. So let's have a look and see what happens with that one. And are they going to do it? Yes, they are. And here we have that graph. So here are two graphs. And although they are similar in shape, their orientation is slightly different. So I'm going to have a look at this on a different package. We're going to look at this on GeoGebra. So here we are in the GeoGebra package, the GeoGebra graphing calculator, and I'm going to enter those two functions in. So to start off with, I'm going to say y equals 2 raised to the power of x, and there we get that graph drawn. The straightforward exponential graph, we recognize it's passing through 1 on the y-axis because 2 to the power 0 is 1. And now we're going to draw the second graph, and that's going to be y is equal to, so I'm swap over here, log, and we're going to the base of 2 for the variable x. And there they draw that graph. So we've got the exponential graph in red, and we've got the log graph in orange. Now, I think this gives you a slightly better view of these two graphs and the fact that these two graphs appear to be symmetrical. In fact, if they were symmetrical, I could put in the line y equals x, and we'd see that that is a mirror line that we've got here. In fact, I can go and use one of the functions on GeoGebra. I can go and take this graph, the exponential graph, and reflect it in the line y equals x, and I end up with the graph that we also seen as the log graph. So the log graph is the inverse to the exponential graph. So I'm just going to take that reflection off there so we can see the two graphs. So here's our exponential graph, here's our log graph, and I'm just going to take a quick snip of this. And I'm going to insert that back into our diagram page. So here we've got our graphs. This is our, the pin, y is equal to 2 to the power x. This is y is equal to log to the base 2 of x. And as you will recall from work that you did last year when you worked with inverses, if I wanted to find the inverse to this function over here, y is equal to 2 to the x, well, the inverse would be obtained simply by swapping your x's and your y's around. And so I would have x is equal to 2 to the power y. And now if I go and take that exponential form and put into log form, I'm just going to say y, the log, is going to equal log to the base 2 of x. And so that's how we can see these two things are inverse functions. As with all graphs, it's always a good thing to understand the domain and range of these functions. So the domain of the log graph is that x is going to be greater than 0. The range is going to be y is an element of the real numbers. So there's our basic log graph. Now it would be worthwhile going on to either Desmos or GeoGebra and just playing around with the graphing function and just taking a look at different types of log graphs. So have a look at what happens to the log graph if we change the base. What happens to the log graph if we work with fractions, if we work with fractional bases, things like that. So go and have a play with those and to help you get a better understanding of the graph of a log function. That's all for this episode. Goodbye.